5.6 sine law, where I explained here, so just to summarize what I just did here, I was showing you that if I give you 3 dimensions of a triangle, depending on which 3 dimensions I give you, we may have congruent triangles or not. So if I give you 3 dimensions side, 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 for sure you're going to draw the same triangle as me, right? For sure we will get the same one. So if I give you, draw a triangle with these side dimensions. If I give you a triangle with the contained angle and 2 side measurements, we will still draw the same triangle, so congruent. If I give you 2 angles with the contained side, then there's no other way but then to connect it this way. We will all get the same triangles. But if I give you 2 sides without the contained angle, so the angle is not between, this is contained, this is not contained, then it is possible to draw 2 triangles from the information I give you. This is called the ambiguous case, which means that we will get 2 possible answers still relying on the same initial information. So if I give you this length and this length, there's actually 2 different ways you can draw that. So you can even measure it. So if you were to measure this and go, okay, I measure this as being 2.7, come over here, 2.7, same thing. So if you measure these 2, they're actually going to be the same length. And there's 2 ways that can still connect to this bottom baseline. This only happens if the angle is acute. If I try to draw this and I have the same idea, so I have the baseline here, I don't tell you how long that is, but I give you the angle and not make it acute, so make it obtuse. So I give you this angle, and I tell you the length here. There's only one way that you can draw the 3rd line. Once it's obtuse, there's only going to be one way. I have no way to connect it any other way, so if this length is supposed to be this, there's only going to be one way. I can't shorten it, because as soon as I do this, I shorten this length. So this length has to be the same. So again, if I measure this and say, okay, this is the length of this side, if I try to get this same length and move it over here, look, it's going to be off the, it's not a triangle. I've missed the baseline. So it only works if there's an acute angle. Okay? And this is called the ambiguous case. The reason why this is important is because sometimes when you get an answer, you're going to get an answer and say, okay, my answer is whichever degree, right, 20 degrees. And you're going to say, oh, wait, but couldn't it also be, and then this is the ambiguous case where you get more than one answer. We're going to talk about that case later on. We'll talk about how this comes back into cast rule. So you might be like, where does this come into cast rule? It comes back into cast rule where you get one answer and you're like, but that's the wrong answer. It should be the other answer. And it's this ambiguous case where we get 2 possible answers. So the way they address it first is just to look at it in a triangle, and then we'll look at it later on when it comes to effect in cast rule, right? Because it comes back to cast rule. If you're like, this doesn't make sense, it'll come back in cast rule where you get one answer and you're like, oh, this is wrong. I know it's wrong. Why is it giving me that? It's because it was ambiguous, the information you gave it, and it doesn't know. Which one do you think the calculator is always going to give you? Always going to give you this smaller one. Right, so it's always going to give you this angle here where it's out here. You're going to have to push it back in and go, but you know what? There's another possible triangle possible. Okay, so first of all, and again, that's where it's going to come into play later on. So this year, for grade 11, we look at just the ambiguous case in general, and then it comes into play next year where sometimes you'll get an answer and you'll go, but wait, I don't think that's the right answer, and you go, why does that happen? And it's because you gave it 2 sides with an uncontained acute angle, and there's 2 possible answers on it. Yes, question?
So you have the small triangle and then with the really big triangle?
Yes, we're going to get 2.
Involved with like that?
Yeah, we're going to, no, not halfway. So we're going to get 2 triangles. So this one, right, where I call it like the normal kind of this open one, right? So I gave you this dimension. I gave you this side, and I gave you this side. So that's one case. That's usually my case 1. So I'm going to call this case 1. Oh, sorry, case 1. Case 1, right? And then I'm going to do case 2, which is the one you're going to have to force it. Your calculator will give you this angle. It likes to give you the acute angle, right? And like I told you, it doesn't know any better. It's giving you the acute angle. It will give you this case. So I'm going to do the sine law. You're going to get this angle. That'll be great. But then you go, but you know what? This is the ambiguous case. There's actually another possible. So if you did this same here and I gave you this measurement here, you could take this line and I could have pushed it in, cut this part off. So what happens is that this bottom line is gone and your triangle is actually pushed in, right? So this length here, and then you get, this is an acute angle, which is what the calculator will always give you. You have to push it in and get this angle here. How are these two angles related, though? How is this angle and the pushed-in angle related? So this is this triangle.
What's the outer angle?
Yeah, but
Back into it?
how are they related, though? Yeah. So it's the outer angle. So this is, these are the same length.
Obtuse angle and the acute angle adds to 180.
Yes, that's it, supplementary, right? So we talked about that definition. So they're going to add to 180. So if I get this angle, there's actually another possible angle if I pushed, it's like pushing the door in, right? So there's two ways that the door can fit. It actually fits here, and it actually, the same door fits here along the same wall. So there's two ways you can push that door in. This one here, the calculator never gets. The calculator always gives you this one because it's, again, it gives you the acute angle. Okay, so it gives you this one. You have to know that you can actually push it in and it will still connect to the base line and get this one. And the connection here is going to be that this adds to 180, and we'll do that in a question.
And so how do we tell if the angles contained in it? Like it'll
Oh,
show-
in the yes, in the description.
It'll
So
say SSA.
yes, so no, it won't say SSA, but in the description I'll say that angle A is 10, side this side, and the other side A is this side. So when you draw it, you'll go, ah,
Like A through
yes, yeah. And you'll see, look, it's not contained between the two. So if it's contained, you only get one triangle. Here, if it's not contained, you'll see it. Okay? So it's pretty straightforward. We're going to just do the sine law one time, just in general, just to do the sine law. And then sometimes what we do is, if we're nice, we give you a hint and say, we might say, hint, there might be more than one case. And then just to remind you to look and say, oh, wait, is there more than one case in this question? So sometimes we give you that hint. So we'll see. Okay, but I'll show you. When we draw it, you'll be like, oh, that's the one. Okay, so here, let's go over sine law. So sine law itself, we know it. We've used it before, so that, and we reviewed a little bit of this at the beginning of the chapter, right? So when we label it, remember that the vertices are the capitals, and the side length here, that would be side A, right? So that's A. And then if this is B, then this would be side B for this length here. And if this is capital C, then this opposite one over here, that would be side C lowercase went here to there. Okay. And then the ratio is A to sine A, B to sine B, C to sine C. And we can have the ratio upside down, right? So either way, both of them work. Generally, when we do the ratio, we try to keep the variable that we're looking for on the top, just so when we do the cross multiplication, it's a bit easier. But it doesn't matter. It works either way, so it doesn't matter. Always works the same way. So let's try to draw the triangle. When we draw the triangle ABC, angle A is 35, angle B is 47, side AB is 15. So we're just drawing a general triangle with two small angles. So I'm going to try to draw that first. So I'm going to do a general triangle. Don't make it isosceles. So I'm just making it purposely not isosceles. A smaller angle, 35, so A, and a slightly bigger angle, 47 degrees, and that's B. So I do something like that. Try to make it not look like an equilateral. A lot of times, all your triangles all look either isosceles or equilateral. And I'm just going to remind you about the phone stuff. You shouldn't be on the phone during the lessons. Okay, taking out your phones, looking at it for a second, responding to stuff. The phone should just be away. Okay, if you don't need to listen to the lesson, then just let me know and let your parents know. Okay, and then we can come to an agreement on that. But other than that, people have been doing the pocket thing, taking it out and just sitting there for a bit. I don't say anything because I didn't want to be on the recording, but now I'm on the recording just reminding you. Okay, can you please just put your phones away? Okay, so we've got the angle B and the angle 47. Again, try not to make it look like an isosceles triangle. Sometimes every single one of your diagrams looks like an isosceles triangle or an equilateral triangle, every single one. So try to make it a little bit smaller, a little bit bigger. Doesn't have to be to measurement, and do not measure it with a protractor. Yeah.
Can I ask you real quick which one is which? Can you draw it? Because I forgot.
Which one is which?
Which one is the equilateral?
Oh, yeah, for the equilateral, yeah. So don't try not to make it look like an equilateral. Sometimes all of your triangles look the same, and like that's the equilateral. So equilateral means don't make them all all equal. This was the 60, 60, 60. Or some people always draw their triangles look like an isosceles, and every single time, no matter what I give them, it's like this is 35 and this is 47, but you're like, are they actually equal? Because they're not supposed to be. So just try to make a little bit smaller, a little bit bigger, and then it makes your diagram more useful. And when you get to the grade 12, when we get to vectors, I make sure that your diagram is more useful because it's supposed to represent something. Right, so I tell you now, just try to make it represent something useful, that this is a little smaller, this is a little bit bigger. Right? Other than that, I don't need you to measure anything. Just try to get it so it makes a little sense. Right? When you're looking at it, if everything looks equilateral, you kind of go, I don't know, they all look like they're the same size. So try to make it a little bit smaller, a little bit bigger, but don't spend a long time on it. Just a little bit smaller, a little bit bigger. Okay, so there you go. Okay. So AB, I'm telling you that the triangle is ABC, so then my last missing one would be C. Right, so do your diagram, and that's the way we're labeling it. So then when we're solving, side AB is 15. So between A to B is 15, so this one is 15. So 15, we got all that labeled, AB, A to B is 15. Solve the triangle, so always provide a diagram. We usually pretty much always ask you to provide a diagram, so we do want a diagram for everything that can provide a diagram. So usually we want that there so we can see it, so I do want to see that. Solve the triangle means that I want you to find everything that's missing. So find everything that's missing. Find all missing angles and lengths. Right, so that's in your brain thinking, okay, you want me to find everything that's missing. So whenever I say solve the triangle, find everything that's missing. Oh, I already said that. No, solve the triangle means other parts. I already said that, sorry. I didn't read the next sentence. Okay, and then I said to 1 decimal, so 1 decimal. Okay. I have 2 angles. As soon as I have 2 angles, you can automatically find the third. So let's start with the easiest step. It's always nice to start with an easy step. So we know that C will equal 180 minus the 35 and minus the 47. Okay, 180 minus the 35 and minus the 47. So then when we do that on our calculator, what do we got? I'm getting 98. Okay, someone double check. Now my calculator. Yeah, you guys are going to have to help me calculate. Misplaced my calculator. Okay, so it should be 98. You need to leave. You can go finish outside. Go finish it outside, though. Finish. Okay, so help me with the calculations. I've got my rough here, but I think it's right. Okay, sometimes I change things. Now, I fill it in on the diagram. Okay, so use the diagram as something useful to yourself. So if you've got the number, fill it in. Make sure the diagram is big enough so you can read your own writing. Okay, and I've had students who copy their own writing badly because they go, oh, I think that's a 2, and then they go, oh, now you've made a mistake just because you copied it too small. So make sure you can read it. It's not about neatness, just at least read your own writing. Make it big enough so you can read your own angles if you write in it. Okay, so big, it doesn't have to be giant, but big enough. So now I have that angle. As soon as I see this scenario, you know that you've got this ratio. This is the sine law calling out to you. So whenever you're going, which one do I use? I cannot use SOHCAHTOA because it's not 90 degrees. So don't even think SOHCAHTOA. Don't let it enter your brain. No SOHCAHTOA if it's not 90 degrees. But I've got this. As soon as you have that, that is right away saying sine law. So sine law is the ratio between them. I am missing side A. So I'm missing side A here. And I'm missing side B. Okay, A and B. So over here, if I'm looking for A, I usually put that on the top of my ratio. But again, it doesn't matter. So I don't care if it's on the top or the bottom. I usually put my unknown on the top. And then I do this over sine of 35. Okay? Then I use this beautiful one here, this one that's perfectly set up, right? That to be the ratio for everything else. So then I go, I know that that is equal to, see this beautiful one here? It's the 15 to the sine of 98. And I match it, right? So the sine goes on the bottom with the angle, and I have the side length here. If you wrote it upside down, that's totally fine. So if you did this, that is exactly the same thing. It doesn't matter. And what you would do is you would bring the A up here, the 15 across there, and still do cross multiplication. So you would do that and then divide it out. It's still fine. But here, the reason why this is a little bit easier is because, look, A, to get it all by itself, right, to get A all by itself, I just need to make this one goes to that side. So it's one step instead of two. It's totally fine if you did this. So if you answered this, I would bring the A up. So I'd go 15 sine 35 equals A sine 98. And then I have to still divide both sides by sine 98, like that. Okay, and then I can get that. So it's still okay, you just have to do two steps. If I do it this way, it just takes away one step. So if I'm isolating A, I just need to bring this one up. Right, division becomes multiplication, and then I can do it a little bit faster and just go A equals 15, bring that up, sine 35, I put the sign after, right, put the regular number, the coefficient here, and then leave the sine 98 here. You can see it's exactly the same thing, right? So that's 15 sine 35 sine 98, same, but in one step versus two. It's not a big deal. It doesn't matter to me which one you use. Yeah. Do I need this step? No. No, you don't? Yes, and we asked this before, right, because you guys are asking about the steps. So the steps I'm going to mark, so watch this. I do want the diagram just so I can follow what you did. If the diagram's wrong, at least I can go, oh, you drew the triangle backwards. That's where your mistakes are coming from. So I need this to basically to tell your story to me. Is like, this is where I started with, so I want to see the diagram. This, I don't need to see the subtraction. So if you do that on your calculator, I'm good with if you just put C as 98. Okay, so I don't yet, right? So last time you were asking about the steps as well. So here, I want to see the ratio. This, I don't need the middle step, right? So again, if you're more comfortable with, I just plug it in. I know it's coming in. I take my calculator out and plug it right in. You can skip this step and go here. So A is approximately, I got 8.7? Yeah. Okay, 8.7. Thank you. Okay, so 8.7. So yes, you can skip this step entirely and go right there. So I'll mark this one and this one for sure. Yeah, thank you. All right, so ask me about the steps, because last time, right, I was like, do you want to show it? I don't want to show the decimals. I don't want you showing me this into decimal divided by that into decimal. Again, I don't know about grade 10 or not, but I never ask you to show it. We're trying to coordinate with the grade 10 teachers to tell them what to tell you guys, right? But I want the formula, and then you can do this if you need it, but you don't have to. You can skip to that. All right, so then the last one, I'm going to use the sine law again to find B. So I'm going to go B to sine of 47 equals, and I'm going to use this glorious one, the one that comes fully filled in, 15 and sine 98. Okay, and then that way all I have to do is bring this one up. And again, if you don't want to show this step, that's fine. I want to see the initial sine ratio. Right, so I want to see that step there. You do not have to show me. The step where I'll bring it over. I'm going to show you because some students do like that step. So I'm going to show you this step. You don't have to. 15 sine 47 over sine 98. So if you don't want to show me, you would go straight to B is. What are you getting? 11.1. 11.1. Okay. I want you for these questions to summarize everything you found. I know that they're right here, and look how beautifully organized it is. I still want you to do one little summary sentence, just very quickly. So you're going to say, therefore, C equals 98, A equals 8.7, and B equals 11.1. I just need those three. Don't tell me what I gave you. So do not list the given info. Right? Does that make sense? I don't want you listing, oh, angle A is 35. I gave you angle A is 35. Don't list that. Don't tell me B is 47. I gave that to you. So just tell me the three things that you found that you were missing. Any other clarification? All right. So that's just regular sine law, just going over regular sine law one more time. Steps, we're good for steps now, right? Because we were clarifying that before. So top, bottom, we're good.